I'd like now to talk about DIBAL reduction, and what we're doing here is we're taking an acid chloride, reacting it with DIBAL, which is considered to be a mild reducing agent, and we are able to get aldehydes in decent yield. The reaction is a classic negative type mechanism with the DIBAL representing an H negative type molecule, which will allow for the production of the aldehyde. I'll show you the mechanism for it in a second on an example, but let's talk about a little bit about DIBAL and what it does. It's considered to be a mild reducing agent because we've got an H connected to an Al, and that's metallic, so that's going to be delta plus, which makes the hydrogen delta negative. But we've got these very bulky isobutyl groups connected to the aluminum, which slows down the passage of H minus. Now let me tell you why that's important. In the case of an acid chloride, there are actually two reductions that could occur. The first reduction is reduction to the aldehyde, but then the aldehyde can be further reduced to the alcohol by another equivalent of H minus. Now what happens is if we use a very harsh reducing agent, something like lithium aluminum hydride, LiAlH4, then we'll tend to get a lot of this in the products. That's because it can't be stopped. The H minus will attack this, and then it will attack the aldehyde group, and you'll end up getting a lot of alcohol in your product. However, if we use the mild DIBAL reducing agent, it slows down the passage of H minus and allows for enough time for this to be isolated without the H minus coming in and attacking the aldehyde as well. So only the acid chloride ends up being attacked by the DIBAL. So again, we use the DIBAL in lieu of a harsh lithium aluminum hydride reducing agent because it will allow for production of the aldehyde without the acid chloride being completely reduced down to the alcohol. Alright, so let me go ahead and show you the mechanism for this. Alright, as I said earlier, it's a classic negative type mechanism, and it's going to follow this pattern up here. And you can see that what's going to happen is we're going to have H minus, and we're going to have the COCl. Now, the Cl here is going to be the Y group. The X group is going to be H negative, or I should say H, with the X negative being H negative, and that's going to be our X group there, and there's our Y minus, which will be Cl minus. So it's a fairly simple mechanism. With the H negative attacking the C double bond O. O negative comes down and kicks out the Cl minus, and we end up with our aldehyde product. Now remember, the reason that this does not have another H negative come in and reduce this further to the alcohol is that the DIBAL is a very mild reducing agent because of the presence of these very bulky isobutyl groups around the aluminum. Makes the H negative less able to get out and attack the aldehyde after H negative's gone in and attacked the acid chloride to give the aldehyde.